And time and distance we have so many problems, because you can ask a problem related to trains, you can ask a problem related to boats and streams, you can ask a problem generally on time and distance. So scope is more. Usually if the paper is given for 50 bits, you may find 3 to 4 bits in time and distance. If the paper is given for 30 bits arithmetic and 30 bits reasoning, you will definitely get 2 bits or sometimes even 3 bits in time and distance. Bigger chapter, you will have to concentrate more on this, right? Next. A car covers four successive 3-kilometer stretches. A car covers 4 successive 3-kilometer stretches with the speeds of 10 kmph, 20 kmph, 30 kmph and 60 kmph respectively. A car covers 4 successive 3-kilometer stretches with the speeds of 10 kmph, 20 kmph, 30 kmph and 60 kmph. Find the average speed of the car. Find the average speed of the car. Simple. Average speed. Average speed is equal to total distance travelled. Total distance travelled by total time taken. Total distance travelled is 12 kilometers, is it not? By total time taken means time is not given. But time you can find out here. What is the time formula? Distance by speed. So this distance, the time is 3 by 10 hours. Next 3 by 20 hours. 3 by 30 hours and 3 by 60 hours. LCM is 60, 18 plus 9 plus 6 plus 3, 36 by 60 hours. 12 kilometers by 36 by 60 means into 60 by 36. 12 threes, 320. So average speed is of the car is 20 kilometers per hour. Right? Average speed is equal to 20 kmph. Next. Excluding stoppages. This problem also I have seen so many times. Excluding stoppages, a train travels excluding stoppages, a train travels with a speed of 90 kmph. And including stoppages, the train travels with an average speed of 80 kmph. How many minutes per hour? How many minutes per hour did the train stops? How many minutes per hour did the train stops? So per hour, how many minutes the train is stopping? Excluding stoppages means a train while traveling non-stop, it travels 90 kilometers in 1 hour. Including stoppages, suppose it gives 1 and 2 stoppings here and there, it travels with a speed of 80 kilometers per hour. If these are the conditions, how many minutes per hour did the train stops? And what would be our calculating method? To travel 90 kilometers, train requires 60 minutes, is it not? 90 kilometers per hour means, because the question is asked in minutes, so 90 kmph I wrote like this. To travel 90 kilometers, 60 minutes are required for the train, non-stop. But with the stoppages, it is traveling only 80 kilometers. How many kilometers it is unable to travel because of the stoppages? 10 kilometers. So, whatever the time required to travel 10 kilometers, that is the timing that is stopping in the stations, is it not? So, 90 kilometers if it travels in 60 minutes, 10 kilometers it will travel in how many minutes? 90 kilometers if it is traveling 60 minutes, 10 kilometers means less time, less by more in 60, 32s and 33s, 20 by 3, that is 62 by 3 minutes per hour the train stops. Suppose it travels this 62 by 3 minutes also, it would have covered this 10 kilometers, then the speed should be 90. Understand? So 62 by 3 minutes the train stops. Next problem. A train 150 meters long, a train 150 meters long passes a telegraph pole in 12 seconds. A train 150 meters long passes a telegraph pole in 12 seconds. In what time will it cross a bridge? In what time will it pass a bridge 350 meters long? You can put it in a general way. A train is crossing a telegraph pole means it is crossing its own length. So 150 meters if it were to cross, it takes 12 seconds. The next, don't put 350 meters. A train has to cross a bridge means train length plus bridge length. So to travel 500 meters, what is the time it would take? So 500 by 150 into 12, 0, 0, 5 threes, 5 tens, 3 4. So 40 seconds. What is the time it takes? It takes 40 seconds. Next. train traveling at a speed of 60 kmph a train traveling at a speed of 60 kmph passes completely another train moving in the same direction with a speed of 40 kmph and having a length of 450 meters in 117 seconds. Having a length of 450 meters in 117 seconds. What is the length of the faster moving train? What is the length of the faster moving train? Observe the problem here. The question asked is, what is the length of the faster moving train? Means the problem is related to two trains, is it not? He asked what is the length of the faster moving train, means one train length is given and other train length is asked. In such cases what you have to do is, total train lengths are not given, you assume. Suppose a part of the distance is given and a part of the distance is not given, is it not? In such cases, think that total distance is not given. Even in speeds also, suppose one train speed is given and the other train speed is not given, think that total speed is not given. So total distance is not given. Speed. Since both the trains are moving in the same direction, speed means higher speed minus lower speed. That is 60 minus 40, 20 kilometers per hour. Usually train lengths we denote in meters. So we want in meters, so we convert the speed. 20 kmph into 5 by 18 means 100 by 18 meters per second. In what time they crossed each other means they crossed each other in 117 seconds. Therefore, distance is equal to speed into time. 100 by 18 into 117 meters. This is in meters per second and this is in seconds, we get in meters. 9 2s, 250s. 650 meters we got. What is this 650 meters? Total distance. Total distance means total length of the two trains. In that one train length is given, is it not? 450 meters if you subtract, you will get the length of the other train. The length of the other train is 200 meters. The length of the other train is 200 meters. Okay. Next. A train having a length of 200 meters. A train having a length of 200 meters passes another train moving in the opposite direction with a speed of 40 kmph with a speed of 40 kmph having a length of 300 meters in 30 seconds. What is the speed of the first train? What is the speed of the first train? Here also, speed of the first train is asked. Speed of the second train is given. A part of the speed is given and a part of the speed is asked. So, total speed is not given, we assume. What is the total distance covered? Total distance covered is sum of the lengths of the two trains, is it not? 200 plus 300, 500 meters. In what time they crossed each other means 30 seconds. Total distance is 500 meters. Time is 30 seconds. So speed is equal to 500 by 30. This is in meters and this is in seconds. The speed we got is meters per second. And usually train speeds we mention in kilometers per hour, is it not? So convert this into 18 by 5. 500 times 0, 0, 3, 6 times. 60 kilometers per hour we got. The speed what we got here is relative speed, is it not? The speed what we got here is relative speed. Since both the trains are moving in the opposite direction, train 1 speed plus train 2 speed is 60 kilometers per hour. First train speed we don't know. Second train speed is 40 kilometers per hour is equal to 60. So train 1 speed is 20 kilometers per hour. So the speed of the first train is 20 kilometers per hour. Next, a boat goes 100 kilometers downstream in 10 hours. A boat goes 100 kilometers downstream in 10 hours and 75 kilometers upstream in 15 hours. Find the speed of the boat in still water. Find, I repeat, water. Find the speed of the boat in still water. What we write? Speed. Speed downstream is equal to speed downstream is equal to speed of the boat plus speed of the stream, is it not? What is said? A boat goes 100 kilometers downstream in 10 hours. Speed means distance by time, is it not? So 100 kilometers distance in 10 hours. So 100 by 10 means 10 kmph. 10 kmph is the speed downstream. Speed upstream. What is the speed upstream means? Speed of the boat minus speed of the stream. What is the data given? 75 kilometers in 15 hours. Distance 75 kilometers traveled in 15 hours. 75 15 is 5 kilometers per hour. Find the speed of the boat, he asked. Directly you add, pluses minuses cancel. 2b is equal to